All right, let's get on track with today's deep dive. We're going to be talking about something that I'm sure you see every time that you are near a railway, but probably never even think twice about.
The bed of rocks under the tracks.
Yeah. You know, ballast.
Ballast.
Ballast, exactly.
The unsung hero of train travel, wouldn't you say?
It is. And we are diving deep today into a technical book on railway engineering to uncover why ballast is way more fascinating than most people think. Diagrams, tables, the works, we've got it all.
We do.
So for those of us who haven't cracked open a railway engineering textbook lately, let's start with the basics. What exactly is ballast?
Okay.
And why is it so important?
Imagine a train,
Okay.
a heavy train rumbling down the tracks.
Okay.
Ballast, that layer of crushed stone and sometimes gravel, that's what's distributing all that weight evenly onto the ground.
Okay, so it's like the tracks foundation.
Exactly. But here's the thing. It's not enough for ballast to just be strong. It also needs to drain well,
Oh, okay.
so that rainwater doesn't pool around the tracks and cause erosion,
That makes sense.
or even worse, instability.
It's like building a road that can handle a flash flood and a monster truck rally at the same time.
That's a great way to put it.
Right.
And that's where the engineering gets really interesting. The source material that we're looking at today really dives deep into the specifics.
Okay.
You know, the size and shape of the stones, the different types of tests they use to make sure that it's doing its job properly. It's really quite a science.
So hit me with some of those specifics. What makes for the perfect piece of ballast?
Well, first off, it's not just any old rocks.
Okay.
It all starts with something called granulometric composition, which basically means making sure you have the right mix of different size stones.
So like Goldilocks in the porridge, not too big, not too small.
Exactly. Too many small particles and the ballast becomes too dense,
Okay.
which blocks drainage. Too many large particles and there aren't enough small stones to fill the gaps, which makes it unstable.
Wow, so there's like a real art to getting that mix just right.
Absolutely. And get this. Different countries have their own standards for this.
No way, really?
This source material specifically mentions the UK, France, and Germany, each with their own unique specifications.
So different countries, different ballast recipes? Who knew?
Fascinating, isn't it? And it really highlights how much thought goes into something we usually never even notice. But it doesn't stop there. The shape of the stones matters too.
No, hold on, wait a minute. They're measuring the shape of rocks now? How does that even work?
They use something called the fleekiness index,
Okay.
which essentially measures how flat or elongated a stone is. Picture an engineer with a caliper carefully analyzing the dimensions of each piece of ballast. It's all about making sure the stones can interlock properly for maximum stability.
I never realized there was so much, like, precision involved in choosing the right rocks. It's like, I'm starting to feel bad for all the times I just, casually walked across train tracks, you know what I mean?
Don't worry, you're not alone, but all this careful selection is for a good reason. Those tracks need to withstand incredible forces. And speaking of forces, did you know that they actually put these carefully chosen rocks through rigorous testing?
Testing? You mean they don't just, like, kick the rocks and call it a day?
Not quite. They have some pretty intense tests
Okay.
to make sure the ballast is up to par. One of the most interesting ones is called the Duval test.
Okay, I'm intrigued. Lay it on me. What's the Duval test?
Get this. It actually dates back to the horse and buggy days. Yeah. They'd basically tumble the rocks in a cylinder and see how much they broke down.
Wait, are you serious? They've been testing ballast since, like, the days of horse-drawn carriages.
It's true. Of course, the technology has evolved since then.
Right.
But the basic principle is the same. They're still looking for the toughest, most durable ballast they can find.
Wow, that blows my mind. From carefully measuring the shape of rocks to testing their durability with methods like older than the automobile. Who knew ballast was so hard?
Yeah, right.
Right.
It's a tough job, but someone's got to do it. But it doesn't end there. We haven't even touched on the Los Angeles and Micro Duval tests or the fascinating world of elastoplastic behavior.
Elasta what now? You're going to have to explain that one.
Basically, it means that those rocks are moving and shifting under the weight of the trains more than you'd think.
Hold on. So you're telling me that the rocks MVE,
They do.
but I thought they were supposed to be, ROCKS.
Right, you think so.
Solid, unmoving.
Right. That's what makes it so fascinating. It's all about finding that sweet spot between strength and flexibility. But don't worry, we'll delve deeper into that in just a bit.
So you're telling me those rocks beneath the train tracks, they're actually, like, moving and shifting around down there. I gotta say, I'm having a little trouble picturing that.
It's not something you would ever notice from a passing train, but believe me, at a microscopic level, there's a lot of action going on down there.
Really?
Think about it. We're talking thousands of tons of metal rumbling over those rocks every day.
Yeah, that's true.
Over time, they're bound to shift and settle a bit.
Okay, that makes sense when you put it that way. But wouldn't all that movement eventually cause, like, problems with the tracks?
That's where things get really interesting. Our source material here actually dives into some of the potential pitfalls of ballast, what can go wrong, how engineers work to prevent those issues.
Okay, now you've got my attention. Hit me with the worst case scenario. What happens when ballast fails?
Well, one of the biggest risks is something called ballast fouling. Imagine, all that perfectly sized, carefully tested ballast we talked about.
Right.
Now picture it getting all clogged up with debris, dirt, leaves, even litter.
Wait, so you're telling me, like, a stray coffee cup can throw off the whole system?
It sounds crazy.
Wow.
But it's true. All that stuff infiltrates the spaces between the ballast, and suddenly that perfect drainage system we were talking about,
Yeah.
gone.
And we know drainage is crucial. You start messing with the drainage, you start messing with the stability of the entire track.
Exactly. And that's when you start seeing issues like track settlement, where the tracks actually sink or shift out of alignment.
That sounds not ideal,
Not ideal at all.
to say the least.
It can lead to anything from a bumpy ride to, in extreme cases, even derailment.
Right.
And it's not just debris that can cause these problems. Remember how we were talking about how ballast breaks down over time?
Right, that whole elastoplastic behavior thing, which, by the way, I'm still trying to wrap my head around the fact that rocks can be plastic.
Well, it's that very behavior that can lead to problems down the line. Think about it. Constant pressure, vibration, extreme weather. Eventually, those sharp edges on the ballast start to wear down.
So instead of, like, those perfectly interlocked stones, you just end up with, like, gravel.
Essentially, yes. And that finer material just doesn't perform the same way.
Right.
Less drainage, less stability. It all goes downhill from there.
Okay, this is all starting to sound a bit alarming. What can be done to prevent, like, a full-on ballast breakdown? Do they just, like, rip up the tracks and start over every few years or something?
Thankfully, it's not quite that drastic.
Okay.
Railways have actually developed some pretty ingenious methods for maintaining their ballast and keeping those tracks in tip-top shape.
Ballast maintenance. There's a phrase I never thought I'd be so interested in. Tell me everything.
Okay, well, one common method is, unsurprisingly, called ballast cleaning.
Okay.
They literally use specialized machines to come in, lift the tracks, remove the old fouled ballast, and replace it with fresh, clean ballast.
It's like giving the tracks a spa day.
Ah, I like that analogy. And then there's ballast tamping. Have you ever seen those machines along the side of the tracks that look like they're vibrating the life out of the rails?
Yeah. I always just assumed they were just, making sure things were, like, firmly in place.
Yeah.
A little rock massage, if you will.
That's a very polite way of putting it, but you're on the right track. These tamping machines are essentially giving the ballast a deep tissue massage, compacting it, leveling it, making sure that it's performing at its best.
So it's not just about, the rocks themselves, but it's also how they're, arranged and maintained.
Precisely. It's a constantly evolving process. And with all the advancements in technology, they're finding even more sophisticated ways to monitor and maintain ballast. They even use ground-penetrating radar now to, spot problems before they become major issues.
Wow, so they're really pulling out all the stops to keep those trains running smoothly. Makes you realize just how much we take for granted, doesn't it?
Absolutely. And speaking of taking things for granted, we've been so focused on ballast here in, North America. We haven't even really touched on how things are done in other parts of the world.
Now that you mention it, I am curious. Are there different, like, ballast philosophies around the globe? Like, do the French have, like, a secret society dedicated to perfectly shaped ballast?
I wouldn't be surprised if they did. But seriously, you've hit on a really fascinating point. Let's jump across the pond for a second and take a look at how ballast varies around the world.
All right, so we're going on a quest to uncover the global secrets of ballast, huh? Where do we even start with that?
Well, Europe's a hotbed of railway innovation, so let's head there first. Remember those varying standards for ballast size we talked about?
Yeah.
Turns out those aren't just like suggestions. Different countries, they take their rock recipes very seriously.
I'm just imagining, like, a French inspector scrutinizing a pile of British ballast with a monocle.
Yeah.
Like, oh, mon Dieu, these rocks are far too irregularly shaped.
So.
It's not that far-fetched. The UK, for example, they've been at this railway game for a long time. They've had centuries to fine-tune their approach to ballast. And they tend to have very, very specific requirements for the size and shape of their ballast.
So what you're saying is British ballast has quite the pedigree.
You could say that. Meanwhile, France, they've got that need for speed. Those TGVs are no joke.
No, they're not.
So they prioritize ballast that can handle those intense velocities. We're talking harder, more durable types of rock, rigorous maintenance schedules to keep everything in tip-top shape.
Makes sense. Can't have those high-speed trains hitting the brakes for a loose rock.
But it's not just about the rocks themselves, though, is it? We talked about geotextiles a little bit earlier. Are those more common in Europe?
That's a great observation. You're right. The use of geotextiles, that permeable fabric that acts as a barrier between the ballast and the subgrade, that is much more widespread in Europe, they're all about that extra layer of protection
Okay.
to prevent ballast contamination and maintain that drainage.
It's like tucking those precious rocks into bed with, like, a nice protective sheet.
Exactly. And it really highlights, I think, a key difference in the philosophy.
Yeah.
Where North America has traditionally focused on, readily available materials, cost effectiveness, Europe seems to be taking a more long-term sustainable approach to ballast.
Interesting. So different priorities kind of lead to different approaches. What about the future of ballast? Any exciting innovations on the horizon that you know of?
Oh, absolutely. Researchers are always looking for ways to improve upon the humble ballast. And one really promising area is the use of recycled materials.
Wait, so recycled materials as in, like, crushed up soda cans?
Not quite.
Okay.
Think more along the lines of crushed concrete, glass, even certain types of plastic. They can be processed to create these aggregates that can actually meet the specifications for ballast,
Okay.
providing a more sustainable alternative to quarried stone.
Now, that's some eco-friendly track work I can get behind. Turning trash into treasure one rock at a time, that's great.
Exactly. And it's not just about the materials either. There's ongoing research into different ballast shapes, interlocking mechanisms.
Wow.
Imagine like high-tech Legos for train tracks. It's fascinating stuff.
Okay, that's just cool. It really sounds like ballast is finally getting, like, the recognition it deserves.
It's about time.
Well, as we pull into the station here on this deep dive into the world of ballast, what's the key takeaway you want our listeners to remember?
I think the next time you're on a train, speeding toward your destination, just take a moment to appreciate that often overlooked ballast working tirelessly beneath you.
Yeah.
It really is a testament to the ingenuity of engineers. They took a simple concept, a bed of rocks, and turned it into this critical component of modern transportation.
I know I will never look at train tracks the same way again.
Yeah.
A huge thank you to our expert for joining us on this fascinating journey beneath the rails.
It was my pleasure. It was a fascinating conversation.
And to our listeners, thanks for hopping aboard for another deep dive. We will see you next time.